Today's video is about the GammaGuard CT007-F radiation detector. The detector is really a good one for detecting all three different types of radiation, alpha, beta, and gamma. It uses a plastic scintillator, and so its background count is going to normally be around maybe 10 or 11 counts per minute. And I've got it running right now on the iPhone, and if you look, it's averaging probably about 50 counts per minute or so, but that's because I have some sources here nearby and it is picking up the signature from those sources. But each one of these sources are a little bit different, so I'm going to demonstrate the detector with each one. So just like all the detectors in the GammaGuard series, it uses the GammaGuard app, and it has a detail page which you can do time counts like a rate meter, determine counts per minute. It also can be used for dose rate in microsieverts or millirentgens per hour. However, for this particular video, we're just going to use counts per minute. You can look at the different modes. And it even has a flowing histogram chart, which we're going to cycle through as we run some tests. So one unique feature I want to point out about the CT007-F is the slidable beta shield on the bottom. So when this beta shield is slid down, you can detect alpha, and when this is slid up, it's good for detecting gamma. And I believe even with a strong enough beta source, the braking radiation or brim with the beta shield up will show an increase in X-ray energy, which will be reflected as a gamma count. So the very first test, I think, which is going to be a really good tell-all, is detecting the very small trace amounts of radiation coming off the potassium 40 decay in regular salt substitute. This is more of a concentrated version of what is found in bananas, and a regular Geiger counter has great difficulty detecting a radioactive signature coming off of salt substitute. So this is going to kind of show you how sensitive the CT007-F actually is. So I'll set this here. You can see the background count right now is about 30 counts per minute. And let me put this over here a little bit, move this out of the way, drop that down. And you can see it's definitely picking up the very slight increase in radiation levels from the potassium 40. So we're right now at about 150 counts per minute. Still going up a little bit. So yeah, about 140, 150 counts per minute or so with the potassium coming off the salt substitute. Okay, so the next test is going to be with this very low activity piece of uranium glass or Vaseline glass. It's a very small little dish that I picked up several years ago. It has slight fluorescence under UV. Looks better in the dark, but you kind of get the idea here. And again, with the beta shield down, let's see what we got. And it's ramping up. And it looks like it's probably going to be about the same, maybe a little bit more than the salt substitute. No, it's let's see, we got about 200 counts per minute. Still going up. Okay, the next one's going to be a thorium lens, which is commonly found inside many cameras from the 1970s and older. This is going to be from a Kodak Teleinstamatic 708. Typical camera. These things were pretty cheap back in the day. And the small thorium lens is this little item right here. And they put out quite a bit, so you're going to see a lot higher of a count rate with this guy than you did with the salt and the plate. Okay, since thorium puts out gamma, we're going to go ahead and it's a little bit stronger of a signature on top of it. We're going to go ahead and put the shield up and just see what we have regarding that. So right now we're about 20 counts per minute. We'll put that right on top and see what we got. All right, that's rocking. What are we? Will we hit 1,000? No, looks like it. No, maybe. About 800 counts per minute, stable. Now, if we drop the beta shield down, I think we should see quite a rise. So let's go ahead and try that. Yeah, that's a big difference. All right, let's move on to a couple others. All right, I'm sure you've seen this in a couple other videos. It's the NucleSpot Static Eliminator. Polonium-210 puts out pretty much almost all alphas, except for the fact that it does have a very small gamma signature. So this one, you're going to see a huge difference on for alpha counts. But let's go ahead and try the test first. And like I said, we're at about 48 counts per minute right now with the beta shield on. So we should get a little bit. Well, not much at all. Really nothing. And I think that's primarily because the Polonium-210 is really decayed a lot. Yeah, we're getting a little bit of a rise over a couple of seconds here. And there could be a little bit of brim X-ray coming off of this too that it's registering, but I could be wrong on that as well. But regardless, I believe most of this is just a very small amount of gammas that come off of Polonium-210. All right, so let's go ahead and try this now with the beta shield down and see what the alphas are going to do when we try to detect them. Okay, that's instant. Because that is one hot alpha source, even in its very weak state. And that's going to take some time to wind down since it really ramped up fast. Okay, so there's a really good example of alpha detection with the CT007-F. All right, so the next test is going to be with a typical antique store find, Fiesta ware, or a typical orange type glazed pottery item. Bauer used to make it back in the day, and they're quite often found in antique stores or even Goodwill or places like that. So they put out some gamma, not very much, a lot of beta, and some alpha here and there. So, but let's go ahead and try this with the beta shield up, and if we get any type of gamma type signature. So we'll just go ahead and set it like that. And there you go. And very similar to the NucleSpot, when we drop the beta shield, you're going to see a very, very strong beta signature coming off of this. And why don't we just go ahead and do that now? We'll drop that down. You had about 6,000, 7,000 counts per minute with the beta shield down. Okay. Okay, second to the last test is going to be this radioactive source, which is a test source from an antique Geiger counter from the 1950s. I've already ran gamma spec on it. It is a radium source. It does put out gamma radiation, all relatively low, and we'll do the test this time with the beta shield up. We're currently at 58 counts per minute. Move this in place, and that was fast. Okay. And we'll go ahead and drop the beta shield and see it really rock. Okay. All right, last test is with a Bendix TG007 spark gap tube. The spark gaps contain a trace amount of cesium-137. This also had a gamma spec run on it about a year and a half, 2 years ago, and it does have a fairly good residual CS-137 peak at around 661 kilo electron volts. And so let's go ahead and test this. It's primarily a gamma emitter, and we got the beta shield up. It's at about 56 counts per minute. We'll go ahead and set that right like that. Let's see where we're at. Most of the cesium-137 off this tube has decayed since it is about 60 years old. But you can see it's probably around, I don't think it's going to hit 500, but 450 counts per minute. And let's go ahead and give it a shot and just see what happens if we drop the beta shield down. A little bit of a change, not too much. Maybe double. Okay. Okay, so that completes the testing. And let's go ahead and look at the different screens that we've got here on the app to see what we have registered over all these tests. So let's go to the details page, and total counts that we've registered is 45,145 since we started. Could be a little bit off because I think I did have to reset this once in the middle of the video. Overall count rate, as you can see, it's adjusting as the time progresses. And you can see this timer section. This is a scaler where you can adjust whatever time you want for timed counts. And once done, it automatically stops and provides a counts per minute and a total amount of counts. Very, very good function for the meter. And let's see, that's a simple mode showing the average count rate and total counts. And this is the histogram showing the different peaks that we have. So each one of these peaks is representative of a different source that we tested. Obviously, the very high peak is the alpha count coming off of the nucleus spot detector, or I'm sorry, nucleus spot source. And everything's fairly in sequence here. You can see what the averaging is on the histogram. And let's see here, go back. And you can actually magnify and look at this stuff a little bit better if you wanted to see what the baseline looked like in the curves of each individual source as it started picking up. And if you zoom in, you can see what the counts per minute were at each individual point in the rise. That's obviously the nucleus spot, I think. Yeah. Okay, so there you go. There's the CT007-F. And I've had this for probably about a little over 2 years now, maybe 2.5 years. Flawless performer. I've had no issues. Bluetooth connectivity, everything seems to be working well. And uses a couple of AAA batteries, and they last fairly long. You could probably leave this thing turned on for, I believe, probably about 3 days solid before the batteries finally wear down. Just turning this thing on and off like you should when you're done using it anyway. It'll last quite a long time. I think the batteries that are in here now have been in here for about 6 months. And one of the things that I've done is I bought this small 1010 Pelican case, and it's perfect for carrying the pretty much all the detectors. They fit in here quite nicely. And you can have this thing running. The Bluetooth operates straight through this thing, so you can use this for any one of the detectors, the F, the N, and a little larger one for the M. And in fact, this one over here is for the T neutron detector. They all seem to work really well as a container for these. Okay, and that's about it. Last thing I just want to point out is it does have its own readout, and it's currently set up where it's registering in counts per minute, although that can be adjusted in the settings to whatever format that you want to have it read out in. All right, that concludes my review of the CT007-F. If you have any questions, feel free to ask.